Good afternoon, everyone. Thank you for attending today's webinar on the reality of the residential prescriptive path. This webinar will be recorded and the recording is accessible to all attendees in about a week's time on the Code Adoption Toolkit website, and as well as all of our previous webinar recordings are on there, so definitely check it out. If there are any issues with audio, feel free to write me in the chat. My name is Erica DeLello, and I'm a project manager for Noresco. This series is sponsored by the Colorado Energy Office with training materials created by Build Tank Inc. And Robbie and I have been working with the Colorado Energy Office to provide trainings just like this one. As you can see here, we've got one more in our regular Wednesday webinar series for just a open-ended Q&A session. So definitely bring your questions, and we'll have a couple of subject matter experts on the line to answer those questions for you. We've also added two other trainings. One is a webinar, and it's on creating or not recreating the EV or PV wheel. So essentially targeted towards jurisdictions that are looking at adopting PV or EV requirements to align with the future state legislature. So I'll send the link in the chat shortly for a place for anyone to register at. The other training that we have going on here is in person actually, and it's about commercial plan review and what to look for in the field. So that's a 4-hour training in person, and it's located in Commerce City. So I will also send the registration link for that in the chat shortly. So most of you may know about, if you've listened into our webinars before, about the Code Adoption Toolkit and all of the resources available, but I do want to make sure to highlight the helpline and continue to spread the word about the helpline. It's available to anyone in Colorado on any of the I codes, not just IECC, but say you have a question about the IFC or a question about a stretch code that is local in your area, or you're considering adopting a local reach code. We're here to support you, your jurisdictions and industry professionals through all of that. So feel free to submit a question and any question at all, and we'll get back to you in just a couple of days time. And you can access this helpline through the Code Adoption Toolkit or through the link that I've shown on the screen here. And lastly, throughout this webinar, we do want to encourage questions. So feel free to write them in the chat or in the Q&A, and Robbie and I will go through those following the presentation. And there is also the ability to raise your hand to ask the question directly to Robbie, and I can unmute you. And there is a survey window that will pop up following the webinar, so please just take a minute to provide that feedback so we can continue to improve on these webinars or create new resources for you all so that you can increase compliance in your area. So today's presenter is Robbie Schwartz, and Robbie founded Build Tank Inc. to be a practical building think tank to do research, education, and work with builders to ensure that their homes not only comply with the codes and programs, but perform. And actually, Robbie just accepted a part-time role at Boulder County as their new homes building advisor for the Marshall Fire victims. So he's a resource available to any of the folks that reside in that area and are looking to construct a new home. So with that, Robbie, I will stop sharing my screen and let you take it from here.
Great. Well, thanks so much, Erica. Appreciate it. Thanks for everybody for joining us today on this webinar. Again, we're going to be talking about the 2021 IECC specifically and the reality of residential prescriptive compliance. I am going to turn off my video until the end when we do more questions and answers so that you can concentrate on the slides. But please, if you do have a question that you want to throw out immediately, yeah, raise your hand and Erica will let you unmute there. So our plan today, we're going to be talking about this new way that the code has been structured with regards to mandatory. What's mandatory mean in this new code? We'll be talking about compliance options a little bit, specifically the prescriptive compliance path and some of the realities there and flexibilities that are there or not there. I'm going to do a quick res check demo, and then we'll talk a little bit about other requirements in the code as well. So the first thing is with regards to mandatory. So in the 2021 IECC, this thing that's persisted throughout the I codes, or persisted at least throughout the history of the International Energy Conservation Code up until the 2021 version, is this kind of separation, I guess, between prescriptive and mandatory requirements. And the reality is that in this section, mandatory has, or in this code, the word mandatory has been removed. And it's been removed because there's a realization that in the prescriptive path, there in essence are mandatory requirements, and requirements that had to be dealt with regardless of the compliance path that you chose to demonstrate compliance with this code with. So now only the word requirement is used, and in essence, requirement means mandatory. You have to do those things if they are a requirement, regardless of the compliance option and regardless of where that requirement shows up in the codes. And we'll talk a little bit more about that here in a second here, but that's the biggest thing, and one thing that does impact prescriptive compliance as well as the other compliance options. So just to review the compliance options that we have, I like to break them up into these categories. Although the first two are in the prescriptive section of the code, I break out prescriptive U value and R value requirements or compliance options versus the prescriptive area weighted compliance alternative, which is some people call it the res check path, or remember, res check is a compliance software, not a compliance pathway, but the area weighted U value trade-off pathway utilizes a software similar to the total building performance and energy rating index pathways. And then in the 2021 tropical climate zone was added, and there's a compliance option for that climate zone as well. And regardless of the compliance option that you choose to demonstrate compliance with this code, there's also the additional energy requirements of the code that you need to do. So in this section, this new section R401.2 application, it talks about these different compliance options instead of having a specific prescriptive section of the code. It's set up that way now. So these additional energy efficiency options are the first thing that we need to address when we're talking about prescriptive compliance. So the section was established, and it's basically saying that you have to choose one of these options, or if you're doing something other than the prescriptive compliance path, demonstrate that your home is basically 5% better than. But in the prescriptive compliance path, you have to choose one of the energy efficiency options laid out in section R408.2. And what are those options? You can choose to have an enhanced envelope performance. You can choose to have more efficient HVAC equipment, more efficient water heating equipment, more efficient HVAC delivery, and or improved air sealing and ventilation requirements here. So with your prescriptive compliance, you have to do one of these things, and you have to demonstrate that you've actually done that when you're submitting for your plan review and your building permit, and also at the end of the process. You might be asked to demonstrate that for, specifically like with the air sealing and ventilation one, you have to be tighter than 3.0 air changes per hour at 50 pascals, for example, and or use an ERV or HRV. So you might have to demonstrate that and turn in some documentation for that. When we talk about this prescriptive compliance pathway, you'll see that in the 2021 IECC that the word, again, prescriptive, has been strucken. It's no longer there in the 2021 IECC. So the building thermal envelope shall meet the requirements of this section, and it goes through demonstrating what different compliance options are available in what used to be called the prescriptive section of the code. Now they're just, an option, another option that you can choose to demonstrate compliance with. You also always have to deal with vapor retarder issues in our climate zone specifically, and that takes you to the IRC to deal with that. But the big thing to know about this compliance option, what we call the prescriptive compliance options, is that they are the least flexible section of the IECC. You only have the option to do better than. You don't really have the option to trade off, except in the area weighted U value compliance option. And we'll talk about that here in a little bit. But you also have to make sure that you declare that this is the method that you're going to use for compliance, and your permit plan set has to have documentation on it in order to demonstrate that to the code official that's going to do a review. So there's actually 4 options within these prescriptive section of the code, this R402 section of the code, that you can choose to demonstrate compliance. There's what we call the assembly U value approach. There's the assembly R value approach. There's the cavity R value approach, and there's the area weighted U value or potential trade-off approach. Now, the reality is that the assembly U value and R value approach really are seldom used. It's really the value of this, especially the U value table, is that it's utilized in the software to be able to do calculations that help us determine if a trade-off works. The reality with the prescriptive pathways is that the R value table, or the cavity R value approach, is the approach that is actually most commonly used, or the area weighted U value approach using a software like ResCheck or RemRate or Ecotrope to demonstrate that the area weighted U values actually work there. What this section of the code really is helping us understand is that the code is trying to always protect the building thermal envelope. So it's dealing, this section, even more so than other compliance options in the code, is really dealing with R values and U values. So R values describe a material's ability to resist the flow of energy. That resistance correlates with the R value number. The higher the R value, the greater the resistance of energy, always from higher concentrations to lower concentrations. So in the wintertime, it's resisting energy flow from inside the house to outside the house. In summertime, it's resisting energy flow generally from outside to inside the house. We have this notion of nominal R value, the R value of the insulation within the cavity. And then the assembly R value is the weighted R value of all the types of materials that create that assembly here. And so we can look at compliance using both the nominal R value or the assembly R value, because the code has done the work for us to equate those two things to mean the same thing. So in terms of the U value table and the R value table, the expression of the resistance to the flow of energy is expressed either in U value or R value, but it's giving us the same quantity of resistance to the flow of R value here. So the U value describes the thermal resistance of the rate of heat transfer through 1 square foot of material. So this mathematically, we can translate between U values and R values here to make that work. The U values apply to the assembly, the R values apply to construction components, and then we can ultimately get this area weighted U value for our assemblies here. So just to kind of give us an understanding, when we're looking at the U factor alternative here, in theory, we could calculate that by hand, but most often we're using a software, and the application is really happening for the assembly when we use a software like ResCheck or RemRate or Ecotrope when we're doing the area weighted U value compliance alternative. But the assembly with the U factor equals this specified zone. So in our climate zone here, we're talking about the U factor in our framed walls of 0.45. And if we do the reciprocal of 0.45, we get an R value of 22.2. And then if we look at the R value table, the R value table's kind of starting point, it does give you some different options for walls in the R value table, but its starting point is a 20 cavity insulation plus 5 continuous insulation. And if we take the reciprocal of that, we get that 0.4. And then if we add in sheathing and air films and other pieces of the assembly, we get that 0.45. So the only reason I'm really going into this detail is to demonstrate that the equivalency of the R value table and the U value table for the different components of our assembly that are detailed out there, they're basically getting at the same thing here. Another way to look at this is to look at kind of an assembly versus cavity R value library entry that we use in the modeling software. So in this case, I have sheetrock and fiberglass bat. I've got OSB, I've got weather resistant barrier and siding materials. I've put into the software that we're using R20 cavity insulation. And with that assembly, taking into account the framing factor, which is about 23% here, that cavity insulation is actually reduced to an R value of about 17. And then if I add exterior continuous insulation, I get that 22 and a little bit more. The similar if we took the reciprocal of that U factor of 0.45, we're getting that R value of 22 and a little bit more here. So again, this is just another way of showing that they're equivalent there. When we move into the prescriptive R value table here, we just have to remember, again, it's talking about what is the R value of the cavity that we're installing that insulation in. When you do the math and demonstrate the U value of the total assembly, or even the R value of the total assembly, it's always going to be less than the cavity R value. So whole wall R value is not equal to cavity R value. And in fact, it can be substantially less, especially when you start taking into account windows that are in that assembly there. So the window to wall ratio becomes something that's really important to think about when we're talking about compliance with the code, because the greater the window to wall ratio, the less the performance of the overall R value of the wall will be there. So when we're looking at specifically the R value table, the first thing you'll see in red here is stuff that's in the errata. So if you happen to purchase the first version of the code book that was released, you'll notice that everything in red here was omitted in that first version of the code. So there are some choices specifically in the wood framed wall R values that you could choose from. In our climate zone 5 here, we see that you can choose between an R30 wall, which would most likely be achieved by a double stud wall cavity. You could choose also a 20 plus 5 continuous insulation, a 13 plus 10 continuous insulation, or actually you could have 0 insulation in your cavity and have an R20 continuous insulation on the outside. So you are given some flexibility here, specifically with your wall R values, but in general, this is considered the most restrictive or least flexible compliance option, because basically the requirement is get that R value in that component of the assembly. So R60 in the attic, for example. You can add more insulation if you want to, but you can't have less than. And thinking about having less than, there are also some other requirements that have to be addressed in order to put in that R60 insulation in that attic, for example. And from that perspective, I'm thinking about raised hill trusses and other things that would be needed and required by the code in order to achieve that R60 in the attic. So we need to think about that as well from the perspective of how restrictive this pathway is. I just wanted to point this out and give you an idea how insulation has changed over time from the 2009 IECC to the 2021 IECC. This gives you an idea. The numbers in black are the 2009 IECC, and then you can see when things have changed. And if they haven't changed up into the 2021, you won't see any purple in that particular row or column there. So if we look at ceiling insulation, for example, in our climate zone, it's changed in the 2009 IECC, it was R38, and then from the 2012 on, all the way up until the 2021 IECC, we were on R49, and then in the 2021, it changed to R60 attic insulation. So, there in some categories we've had some big changes, and in some we haven't. Things haven't changed. Floor insulation, for example, and rooms over garages or cantilevers, for example. It's been pretty consistent at an R30, since the 2009 IECC. I think that would be one area that would be ripe for some change. Maybe in the 2024 IECC, we could get some additional efficiency from our floor systems and whatnot. So again, I just wanted to remind us of this idea that the mandatory has been taken out of the code. That word has been taken out of the code. So we want to think a little bit about terminology and how things are used now. This word requirement has taken the place of mandatory, but mandatory meant items that should not be traded off. So requirements, in essence, must be met by every compliance path or option, unless there's a specific exception written into the code. And there are lots of areas where exceptions have been written into the code. The requirements are found in specific sections or in tables embedded in the code language there. So requirements might be obvious, but requirements also in some cases are not obvious. Requirements, however, are basically mandatory, regardless of where they show up in the code. It is a requirement, and requirements, just kind of from the definition, means that it's mandatory for the code unless there is an exception that's written in the code here. Now, prescriptive requirements, these are requirements that can't be traded off in most cases and must be met when using the prescriptive compliance path and met when using the other compliance paths. And this is ultimately what created the confusion in the past and why the word mandatory was removed from the code. So for example, attic eave baffles are probably the best example of something that was in the previously described prescriptive section of the code. And so some folks believed that when you used a performance compliance option in the code, you didn't also have to install attic eave baffles in a ventilated attic space because it was specifically in the prescriptive section and it didn't have the word mandatory by it. Now we have a clear understanding that it's a requirement, attic eave baffles for ventilated attics, and it's a requirement regardless of the compliance option you do. It's really a requirement based off of, are you doing a ventilated attic or a non-ventilated attic there? So that leads us to the performance approach, which allows the use of trade-offs to meet specific R-value requirements of the code that ensure equal or better performance there. And the performance path does not override the requirements of how to install efficiency measures there. So in essence, you can trade off R values and U values, and depending on the compliance option that you use, you might also be able to trade off air tightness and duct tightness and those types of things. But the easiest way to think about this is that requirements are all about how you install something, and trade-offs are all about R values and U values. You're allowed to trade off R values and U values, but you can't trade off how those R values and U values are actually installed. Those things are installation details, are the actual requirements that float over all the compliance options that you're allowed to have here. So let's describe trade-offs and what did actually trade-offs mean. So a trade-off refers ultimately about putting something more in one assembly so you can put something less in another assembly. This is a means of providing flexibility in the code for builders to stick with or build assemblies that maybe they were used to or are more innovative, or something like that, but maybe don't actually meet the R value or U value requirement for that particular assembly there. So if I can balance my equation here, I can keep the seesaw balanced here and do something less in one location and something more in another location, then I can do a trade-off here. And we demonstrate that by using a software. But in this example, for example, you can look at the blue ball here as my desire to move from R60 attic insulation in climate zone 5 in the 2021 IECC to R38 attic insulation. And there might be a variety of reasons why I want to do that. That we can talk about here in a second, but because I've reduced the R value from 60 to 38, that means that on the other side of the equation, I need to do something more. So in this case, I'm going to do slightly better windows, and I'm going to build a tighter than 0.3 air change per hour house, and maybe I'm going to reduce my duct leakage here. You know, maybe I need to do all three of those things, and maybe I just need to do one of those things in order to trade off the lower attic insulation from 60 to 38. But this gives you the idea that the energy budget or energy equation needs to be maintained in that balance. And I can trade it off by doing something more in one location if I choose to do something less in another location. And that's how the trade-offs actually work, regardless of the compliance option that you're doing. It's just the compliance option restricts what can be traded off, not that you can do a trade-off here. And we'll talk about the prescriptive trade-off compliance option here in a moment. Before we get there, though, because requirements are required now, regardless of the compliance path that you use, all requirements are required. And that was true in the past as well. It just wasn't as clearly defined as it is now. They now created in the 2021 this mandatory requirements table here. So in that R405 performance compliance option or the energy rating index compliance option, the R406 section, you see that attic eave baffles are required. You can see it here. Hopefully you can see my arrow in both of these tables here. So now it's crystal clear that attic eave baffles are required regardless of the compliance option, because the word prescriptive and mandatory have been removed from the code. It's just a requirement. And if it's applicable to the house that you're building, meaning that you're doing a ventilated attic, then you have to install that attic eave baffle. And so this is just a reminder that in these different sections of the code, there are requirements that you need to do, regardless, again, of that compliance option. Now, they aren't spelled out in a table for the prescriptive compliance section or compliance pathways, because in that section, the R402 section, the the requirements are actually spelled out in that section. So it's deemed to be obvious that those are requirements for those compliance options that you choose there. The other thing that we need to know is that their specific requirements in other areas of the code. So specifically in this R402 section, there's this R402 section that goes from R402.2.1 through 0.12. So there are 12 things that are talked about in this section of the code that include requirements. Starting with ceilings with attics and ending with sunrooms and heated garages. So if you're building with steel framing, or you're doing a floor system or a basement or a sunroom, you need to look at these sections of the code, again, regardless of the compliance option that you're using, and see what the requirement is. And sometimes the requirement mixes up R values and installation requirements. So you need to remember, if you're dealing with an R value, you potentially can do a trade-off. If you're dealing with installation issue, it's a requirement. You've got to install it. So an example of that specific to the prescriptive compliance option is the ceiling with attic spaces. So in our climate zone, we're dealing with R60 here. So it says that you can basically reduce the R value to R49 from R60 wherever the full height of uncompressed R49 insulation extends over the top plate at the attic eave. So the first thing we know is that there is an installation requirement. You have to install insulation that extends over the wall top plate at the attic eave. Now, the R value of that insulation that's installed over the top plate can vary depending on the compliance option that you use. If you use the R value table as your compliance option in that prescriptive section there, you have to install R49 over that top plate, which also means that you probably are going to have to install a raised hill truss in order to get the full height of R49 insulation over that top plate. Again, it's restrictive, and it potentially adds additional requirements in order to do that. But if I decide to trade that off, I could potentially go, in theory, I could potentially go to zero insulation over the top plate. But most likely you're not going to actually be able to do that in the trade-off calculation within the software. So let's say I go to R30 over the top plate or R38 over the top plate. I can do that, but it means that I can't use the R value table prescriptive compliance option in order to do that. I have to move to a more flexible option, which within the prescriptive section of the code is the area weighted U value trade-off option there. So, but regardless of the insulation that I decide to put there, the R value of the insulation that I decide to put there, I need to ensure that the full height of the insulation that I choose to put there extends over the top plate, which means that really almost always you're going to need some sort of raised hill truss. With an R60 insulation, you might need as high as maybe a 16-inch heel on there. With a 49, you start to be able to reduce that to an R30. I still need, about 6 to 8 inches of space there. And then if it's a ventilated attic, I need to take into account the addition of the air space that's needed here to get my attic eave ventilation air up and over the insulation through this ventilation space here. And we're not going to go into it, but there are also requirements for how that attic eave baffle is actually installed in the 2021 IECC that are different than in the other IECCs, the previous versions of the IECC. The biggest difference is that you're required to have continuous soffit eave baffles, regardless of if you have skip or continuous soffit venting there, so that we get that air moving up and over the insulation and not penetrating the insulation. Another one of the things that we need to think about in this section of the code, these requirement section of the codes and how it impacts the prescriptive compliance option here is foundation slab insulation here. So it says that insulation shall extend downward from the top of the slab on the outside or the inside of the foundation wall. So the first thing that we need to understand is that the R value that's associated in the R value table to slabs is specifically talking about slab edge insulation. And these additional installation requirements are dealing with the installation of slab edge insulation that's correlating to that R value there. The insulation located below grade shall extend 2 to 4 feet, depending on the table. In our climate zone 5, it's 4 feet. So it needs to go down from, in essence, the sill plate, the top of the foundation, down 4 feet. There are some exceptions where you could go vertically with that insulation to the outside with that insulation, or potentially to the inside if it's a heated slab as well here. When installed on the inside between the stem wall and the slab, the top edge of the insulation may be cut at a 45. So here's an example of the insulation being cut at a 45, but the reality out there is that these installs that are demonstrated here are really the best way to do it. Generally, concrete tends to crack at this 45, which is an issue here. This is just replacing the 1/2-inch expansion joint material with 2 inches of R10 foam, or you might even be able to trade it off to 1 inch of R5 foam here as your expansion joint now, but also as your slab edge insulation here. Now the code requires that it be installed in a continuous way from, in essence, your sill plate down to your footing or 4 feet down there. This is what they're trying to avoid, is this heat loss, this thermal bridge through the slab edge here. And so that R value that's talked about in the R value table is really talking about the R value of the slab edge insulation. You have to go to footnote, I think it's footnote B in the R value table to understand what's the R value requirement for under slab insulation if you are doing a heated slab. And that's what figure 4 is talking about. If you have a heated slab, you no longer have to bring the insulation all the way down to the footing or 4 feet down. You now are starting to go underneath the slab with insulation, so that your heated slab, all that heat is driven up into the conditioned space of the house there. The slab edge requirement continues and says that it shall be installed in accordance with the table, which is basically the R value requirement there. And then it is footnote D, not footnote B, that says required slab edge insulation R values for slabs is indicated in the table if your slab is heated. So R5 insulation shall be provided under full slab area of a heated slab there. You're allowed to go vertical to the outside to do like a frost protected slab there. So what I'm pointing out here are things that are requirements for the prescriptive path, but also potentially there are some trade-offs because requirements often mix R values and actually how you install them. So remember, anything that's dealing with an R value can be traded off. Anything that's dealing with installation instructions, those things can't be traded off. But the intent of the code specifically says that the code is intended to provide flexibility, to permit innovative approaches and techniques to achieve this objective. So as the Dalai Lama says, learn the rules so you know how to break them properly. Understand the code and where it gives you flexibility. It gives you flexibility in these trade-offs and these trade-off approaches, but the trade-off approaches use softwares. So how does the software work? So the basis of the software is saying the difference, it's trying to understand the difference in the temperature across the building component so that it can determine how the first law of thermodynamics is going to work. And the first law of thermodynamics says that energy is going to move from higher concentrations. I'm sorry, it's the second law of thermodynamics. It says energy is going to move from higher concentrations to lower concentrations, or from hot to cold in essence. So the software is describing the building thermal envelope in relationship to its delta T location. So the delta T is the temperature difference, and it's describing the direction of the heat flow from higher temperature to lower temperature differences. So in this picture case, it would be from inside the house to outside the house through the building thermal envelope there. And then the software creates what we call a reference home. And inside the software, it creates a geometric twin of the reference home. So we have the rated home and the reference home, which is the geometry of the house that you're actually demonstrating compliance for. On the reference home side, the reference home is a standard set of house specifications that generate a specific, consistent, and quantifiable energy performance. So in essence, the specifications of the energy code are overlaid onto the reference home. The specifications that the builder wants to build to are overlaid on the rated home here, and they're compared to each other. And we can have an IECC reference home. You have reference homes for energy rating index. Energy Star is a reference home, and we're starting to see utilities have these reference home as well. So to recap, we have the reference home versus the builder's house here. Remember, they're geometric twins of each other inside the software. The reference home is overlaid with maybe the prescriptive U values or R values that are coming out of that table. The builder's house, so the builder might say, you know, I don't want to put R60 attic insulation in my attic. I want to put R30 in my attic and R20 in my walls, and I don't want to do slab edge insulation. And therefore, if the builder's house has the same or lower area weighted U value, it meets the intent of the code. And that's ultimately what the UA trade-off compliance path in the prescriptive section of the code is helping us do here. So the reality is that you have to jump over to the ResCheck software in order to utilize that compliance option. There are other softwares that do it as well. Some energy rating softwares like RemRate and Ecotrope do this calculation as well. I'm going to actually show you the, an example in the, I'm going to show you an example of ResCheck right now. So I'm going to change my screen here, and we are going to put up this screen 2, and we're going to go over to ResCheck here. So this is the ResCheck software here. It's demonstrating compliance to the 2021 IECC at 7% better than the IECC, which is interesting to me because I have only put in the R values and U values that are specific to the 2021 IECC R value table there. So I would think that I would be closer to 0 compliance. In essence, I'm being compliant by being, equal to, but my guess is that the window to wall ratio is low enough that I'm actually doing better than code by just using the code compliance features here. So you can see I'm using an R60 attic. I'm using a 20+5 wall. I'm using a 0.3 U factor in my windows, which is a requirement for climate zone 5. I'm using R15 continuous for my basement wall. And this is a walkout basement. So I have some slab edge that I wanted to show you, which is an R10 here. So the first thing that we see in this is from a contractor's perspective, they want to trade off probably 3 things. They want to trade off attic insulation. They want to trade off the R5 continuous exterior insulation in their framed walls. And they probably want to trade off the slab edge insulation at R10 here. The reality in the 2021 IECC is that although this provides flexibility, it doesn't provide enough flexibility to trade off all three of those things here. So I'm going to trade off what I think is the builder's greatest desire here. I'm going to trade off the R20 wall because 20 wall plus 5 continuous insulation. So really what I'm going to trade off is the R5 insulation, because a lot of builders now are using R23 blown fiberglass 2x6 walls. And I want to get the benefit of that R23 wall there that I'm going to pay for anyway. And so maybe I can do just a trade-off there. So I'm just trying to trade off an R23 cavity insulation for R0 continuous insulation. And I'll hit compliance here, and it shows that that works. Interestingly enough, that works here. The other thing I might want to take into account is that the standard windows that are coming into my house these days is already lower than 0.30, the minimum requirement here. So I'm going to take advantage of, let's say I get on a regular basis, the windows that I order are a 0.27 rather than a 0.30 window here. And so I want to take advantage of those things that I'm already doing that are going to be the most cost-effective way for me. So this gives me an additional budget, in essence, to trade off. So maybe I want to look at, since I'm up at 0.54 better than what I need to be to comply with this compliance option, maybe I want to look at lowering my attic insulation from R60 to R49 in my attic. So if I hit compliance here, I'm still better then. So I'm not going to spend much more time doing trade-offs here, but this is ultimately what somebody's going to do when they do a basic energy model. This is a basic energy model, and I can do this to try to figure out what is the most cost-effective way to build my assemblies to meet the compliance with the code, and also what is the best assembly for me as a builder that I want to build and I want to warranty and I want to give to my clients out there. Ultimately, what do I want to give to my clients is the big question here. So I'm going to go back to my screen, which is the ResCheck screen. And can everyone see the ResCheck logo? I'm assuming that you can.
We can.
Okay. So and we're going to move on and talk a little bit more about some of the mandatory requirements in our last 10 minutes here. So remember, in the mandatory requirements, there's some requirements that are new to your construction documents. You have to talk about the compliance pathway that you're doing. So you're going to have to actually tell the code official that I'm using the R value table as the basis of demonstrating compliance, or I'm using the area weighted compliance option if you're using these prescriptive things. And you also have to show details, more details that demonstrate these requirements in the house. So these would be examples of some details that you would have to include on your construction documents for drop ceilings or the air barriers behind tubs, for example. You also need to demonstrate the building thermal envelope of your house. And the building thermal envelope ultimately is providing this boundary between conditioned space and exempt unconditioned space. It's an assembly of things that are creating the continuity of our air barrier system and our thermal barrier system, or our air barrier, our air control layers, and our thermal control layers throughout the house. And most of the requirements that are required in the energy code are trying to ensure that you get that continuity all the way around the house. So this part of the code is asking us to basically do this red line test. Put your pencil to paper and draw a continuous line around your building thermal envelope in several sectional drawings. And if your pen has to come off the paper, that's an area that is probably going to be an issue for in ensuring that you're going to have that continuity of your building thermal envelope, which is a requirement of the code here. So again, get those air sealing details on the documents and ensure that that's happening here. I don't know why I have this twice here. The other requirement that is specific to the energy code is either showing the R value label on each piece of material that is added to the house, each piece of insulation material that's added to the house, or providing a certificate from the installer that is demonstrating that materials that don't have an R value mark on it are actually installed to the R value that's required by the code or required by the trade-off option that you're using. So this Optima blown fiberglass material, I might assume has an R value of 23 in a blown 2x6 wall, but the insulator actually has to demonstrate that with a certificate, and that requirement is in Chapter 3 in R303.1.2 section. So that's super important. You also have to provide the certificate. There's some new things in the 2021 code that are required on the certificate, telling the compliance option that you're using, or PV panels, for example, are new requirements on this. If you're using the prescriptive section of the code, most of those compliance options don't utilize a software. And I'm not even sure that ResCheck offers this certificate. You're probably going to need to get a hand-developed certificate. This is one that I created on a software. I just used a Word document, really, that I fill out when I'm working with a builder that's using the prescriptive option of the code. But it has all those things that are required on the certificate, and this certificate ultimately gets signed by the builder and then posted in a conspicuous location there. Remember that all of these insulation installation requirements have to be included in the compliance option of the code, and these air barrier, air sealing, and insulation installation requirements have to be included in your compliance with the code as well. These are generally things that are inspected for during the construction process and have to be abided by, in essence, there. Now, the things that are bulleted on the left-hand side of this slide are things that have been updated in the 2021 IECC. So how this table works is the component is dropped down on the left-hand column. The air barrier requirement is in the middle column, and the insulation installation requirement is in the right-hand column. The general section is basically outlining general details. It's basically saying where you don't have continuity of your air barrier system, add a supplemental air barrier in these general component areas throughout the house, going from the rim joists to the walls to the garage separation and so forth and so on. But where other areas, other components that aren't specifically called out, if you see an issue like a hole in your air barrier, you still have to get that fixed in those locations as well here. So air barriers are defined as assemblies that are joined together. An air barrier may be a single material or a combination of material. In essence, what that table is trying to do and how it's defined in the code is building off of a belts and suspenders approach that the code has to the air barrier systems of the code. The air barrier on the interior side is primarily drywall. The air barrier on the exterior side is primarily exterior sheathing. The code is looking for the continuity of both these things to enclose insulation and have continuity of your insulation in that building thermal envelope. And the code is saying where there's not continuity, you need to add a supplemental air barrier. Now, the code doesn't say exactly what you have to use for that air barrier material, so I'm going to add these key attributes of air barrier materials that you can use to decide what air barrier you're actually going to use to achieve these requirements. So the big thing is that you have continuity, and that's why the code likes this idea of assemblies of air barriers, the interior drywall and the exterior air barrier sheathing there, and then maybe you're adding weather-resistant barrier to be part of your air barrier systems, knowing that the weather-resistant barrier, that Tyvek, for example, on the exterior, is primarily a bulk water barrier or control layer. But if it's installed in a specific way, it can add to that continuity of your air barrier and help that as well. Strength is a big component here. So rigid air barrier materials like OSB, drywall, foam boards, thermal plies, those work much better than flexible air barriers here. Durability is a huge issue. So placement of a correct air barrier in the correct location. Think of attic knee walls and the attic side air barrier that you need there. It needs to be durable. It needs to last the life of the house. And again, that's why stiffness is so important, rigid air barriers, and ultimately air barriers that are impermeable. So continuity is a huge thing that's talked about in that table. So these are just two, I'm gonna give you two quick examples of where the air barrier has not been continuously applied. And in this case, it's at this porch roof connection, which brings up the notion that about 90% of the air barrier details are actually the framer's responsibility. They need to get the continuity of the sheathing, and in this case, the weather-resistant barrier behind the trusses that frame out this front porch area before the trusses are installed here. So it's a sequencing issue. The framer has to see it. They need to get that continuity done first, and then do the overframing for that porch roof. Otherwise, the porch roof is directly connected to the floor system of the house here, and we have a very inefficient assembly here. Here's an example of a detail that should be included in the construction documents. That's what that requirement's talking about, so that you can get this detail done correctly. You have the continuity of your air barrier system, your weather-resistant barrier going down here, and you have no connection between the unconditioned space and the conditioned space there. Another quick example would be stair stringers. We often have a discontinuity of our interior air barrier system here, and we often insulate underneath the raised platform for our stairs on an exterior wall, but we also need to get that air barrier against it, the interior air barrier against it here. So in this case, they've added a piece of thermal ply across the stringer. They'll bring the drywall down on top of the thermal ply on both the top side of the stringer and the underside of the stringer to get an assembly that has that continuity there. So to conclude here, the prescriptive compliance path, again, is the most restrictive compliance path. Again, unless you're using the area weighted compliance option in that prescriptive section, you're not going to be able to trade off R values and U values. So one of the interesting things that I'm learning in my work with the Marshall Fire rebuild is that the majority of the builders are custom builders. And the majority of the time, they are myopically focused on the R value table there, which is not allowing them to figure out the most cost-effective way to meet the intent of the code. The home builders and the other associations out there are talking about the crazy amount of money that is needed to move from the 2018 to the 2021 IECC, when in reality, it's not a lot of money, and in some cases, it's actually no more money to go from the 21 to the 20. I'm sorry, from the 2018 to the 2021 IECC, depending on the compliance option that you choose and the flexibility that you get through trade-offs. The area weighted U value trade-off is the only trade-off mechanism that you have in the prescriptive section of the code, but you do have other options like the building performance option that gives you the ability to trade off house tightness for R values or duct leakage for R values, reduced duct leakage for R values there. So thanks so much for spending an hour with me talking about the prescriptive pathway and some of the other requirements that are required and how they impact the prescriptive compliance options there. If there are questions, I'm happy to start thinking about those.
Great. Thanks so much, Robbie. That was a great overview of the prescriptive path. So I'll go ahead and just remind the attendees, feel free to submit a question in the Q&A or in the chat, and Robbie and I will field those questions. If you do need to move on because it's the top of the hour, we understand. But feel free to either email Robbie or send a question to the code helpline if you have a question that comes up later. And so with that, I'm going to go ahead and stop the recording.